Sample problem 10-02. Sketch an angular acceleration versus time graph given the angular velocity versus time graph shown for the same time interval. So the key thing here to remember is that acceleration is always the rate of change of velocity. And on a graph, rate of change is slope. So for us, the thing we're going to sketch, alpha, is going to be the slope of the omega curve, just like A is the slope of the V curve. All right, so looking at our three sort of intervals, if we take this interval, we can see that we have a slope which is positive but constant during the first two tick marks. So let's say something like this. And then if we take this interval, it's horizontal. The curve is horizontal, so the slope is 0. And then if we take this interval, we can see that the slope is both negative and about twice as much as it had been in the first case. So I'm going to say something like this, but it's constant throughout. And then finally, if we take this interval, we see again that the slope is 0. Now, you might have a lot of legitimate questions about what is actually going on in like this region. And what we're getting here is that there is an aphysical kink in the curve here. So we get an aphysical jump in the value here, and likewise jumps here and here. But the fact of the matter is, if you argued that physical curves are never sharp cliffs, you'd actually be right. And it's a little bit of a glitch of the graph. You can think of it as where we are, our change is so tiny in time that it just doesn't show up, and that would make the rollover infinitely sharp.